Good day, everyone, and welcome to the virtual workshop on exploring new tools in CIPAL to assess land use and land cover changes and produce greenhouse gas emission estimates. As you know, this workshop is organized jointly by the Group on Earth Observations and the GEO flagship Global Forest Observations Initiative, gfoi. We are pleased to also welcome the participation of gfoi lead partner, the Food and Agriculture Organization of the United Nations, FAO, and the Task Force on National Greenhouse Gas Inventories of the Intergovernmental Panel on Climate Change, Ipcc TFI. Next, please. My name is Sara Venturini, and I'm the climate coordinator at the GEO Secretariat. I'd like to give you just a quick overview of the workshop structure. As you know, the workshop is run over 2 days and aims to assess tools that are capable of operating on the CIPAL platform or potentially capable to conduct spatially explicit land cover change monitoring to support greenhouse gas accounting in the AFOLU sector, meaning agriculture, forestry, and other land use. So today, after some opening remarks by the GEO Secretariat, gfoi, and FAO representatives, we will have a session to set the scene on the greenhouse gas estimates from the AFOLU sector with presentations by Ipcc, TFI Technical Support Unit, and the 2 GEO initiatives that are present today, Digital Earth Africa and GeoTrees. Then there will be a 20-minute break for lunch or dinner or breakfast, followed by an introduction to CIPAL and the first part of the demonstrations by 2 software developers today. And to conclude, we will have an initial discussion on potential collaborations, which will be continued tomorrow, following the second part of the demonstrations. Next slide, please. Just some instructions on how to participate actively in the meeting. First of all, when you are active on Zoom, please indicate your full name and affiliation. This will simply allow us to get a feeling for the audience when you interact with the panelists. And you can do that by posting your questions in the Q&A box as the speakers and demonstrators present. And they will do their best to respond in writing, and the moderator will pick them up for them to respond during the short Q&A session and the panel discussion at the end. You may also raise your hand if you want to speak up during the moderated discussion session. And finally, be aware that we are recording this event and we will be posting it on the GEO website for future reference. Now, I'd like to introduce you to the 2 co-chairs of this workshop, Gilberto Camara, the GEO Secretary Director, and Tom Harvey, the GFOI Office Manager. And Gilberto will now present the workshop rationale and the process envisaged around it. Please, Gilberto, you have the floor.
Well, thank you very much, Sarah. I think you could keep the slides on. Okay, so my heart welcome to everyone. We are very pleased as the GEO Secretariat together with the GFOI to have this workshop. It's a different kind of workshop. Normally we have workshops where people present what they're doing, but this is a different flavor. We, the GEO Secretariat, recognize the value of the partnership that has been established around GFOI. And we consider that the ideas that have been put in place around the development of the CIPAL platform are extremely important for establishing a strong global community of members that are able to empower themselves to produce their estimates of land use change, AFOLU, according to the Ipcc, and obviously to support their reporting of greenhouse emissions, removals, and reportings to UNFCCC under the RED agreement. So the important point here is we want to empower the GEO members, which are the GFOI member states, to do their work. And in so doing, we first of all have benefited and will benefit enormously from the support of the Ipcc. The Ipcc has been very forthcoming, and I would like to thank to Sandro Federici, Kali, and Lucia, and Thelma Krug, to tell us what they require. It's a very important point because the Ipcc is saying what we expect countries to produce and what we expect countries to report in terms of the established conventions. And this will frame what comes next. And what comes, I think the next slide, please. So what comes next? What comes next is a community of developers which are represented today, and very much thanks to all of those which accepted our invitation, to say free and open source software that extracts AFOLU information from Earth observation data. So these are the tools, or some of the tools, that hopefully will be made available in CIPO. Now, we have been fortunate to have a number of tools, including the BFAST from Vian Verpessen Binding University, satellite image time series analysis from INPE Brazil, continuous change detection and classification from Boston University, global forest carbon flux model from WRI, the forest canopy disturbance model from JRC, and the Sentinel-free cloud-free annual composite for RED+ from JRC as well. And we have been extremely fortunate not only to have the software developers, but to have a number of external reviewers. And I was telling them, you are the big guns. We have a really, really impressive roster of experts here with us: Nancy, Curtis, Martin, Inge, Frederic, Sylvia, Maria Jose, Frederic Achard, and Thomas. And their role is to really review the tools and give advice both to GEO and GFOI, but also to the tools developers, because they sit in a position to say how far or how much effort would be required additionally to what has been done now in order for these tools to really increase their ability to support AFOLU related measurements in CIPO. And so this is, of course, what we expect the external reviewers to provide us, their expertise, what is missing. And on the basis of that, we hope that the developers, the software developers, will respond with their capabilities and including their needs to further support CIPO and to further support the member states to increase their ability to respond to the Paris Agreement, to UNFCCC agreements, to the Global Stocktake, to the RED+ agreements, and so on. So we are bringing together a unique coalition of those, the Ipcc, the GFOI R&D community, a number of software developers, all connected, and the FAO that runs CIPO, everybody is connected to the same goal: empowering the member states of the world, of GEO and GFOI, to report better to UNFCCC. I think this is a very noble goal and very important, and I'd like to thank everyone for being here today. Thank you so much.
Thank you, Gilberto. Tom, would you like to say a few words on behalf of GFOI?
Yes, for sure. Thank you, Sarah, Gilberto, and all GEO Secretariat colleagues for your efforts in organising this workshop. I have to say from the outset that it's been a real pleasure working with you all in organising this, and I'm very much looking forward to the next 2 days of discussions and the sort of subsequent follow-up from there to see what we can make of this. So I have probably met a few of you before, but by way of background, my name is Tom Harvey, and I'm the manager of the GFOI office, which is based out of FAO, but functions as an independent secretariat for all GFOI partners, components, and activities. And so Gilberto has already done a really nice job of setting the scene for the workshop. So I won't try to repeat or complement anything that he said there, but I'll just provide a quick overview of, I guess, the GFY context for why we're involved here. And I'm sure many of you are already familiar with GFY, but just to clarify, GFY is essentially just a voluntary partnership for coordinating the delivery of international support in forest monitoring to tropical countries. GFY tends to be many things to many different people, but ultimately it is the product of the collaborative efforts of our partners, collaborative efforts such as this one we're here for today, who, with all of our partners coming together to try to, I guess, identify outstanding country needs or gaps in knowledge or in their capabilities for forest monitoring and emissions measurement, reporting and verification. And then collectively working together to see how we can, I guess, best help countries to fulfill these needs in the most efficient and effective means possible. So utilizing partners' comparative advantage, leveraging each other's resources, and generally, I guess, working together to provide a larger and more cohesive package of support to tropical countries than any one partner could provide alone. So GFY works across, I guess, 4 components in capacity building, data coordination, methods and guidance, and R&D coordination. And I guess the MGD is sort of the key cross-cutting resource for GFY, and I guess serves as a kind of a backbone or core syllabus for the initiative. The guidance connects, I guess, country reporting requirements from UNFCCC decisions with the Ipcc's good practice guidance for national greenhouse gas inventories. And as many of you may be aware, the 3rd edition of the MGD was published, I believe it was in August last year. And many of you on the call were centrally involved in this, not least of which is Maria Jose Sanchez as the chair of the MGD Advisory Group, who is here with us as a reviewer today. And of course, Carly Green, who we're going to hear from a little bit later, although she's here in a different capacity working with the Ipcc's TFI. So I just wanted to acknowledge their contributions and many others on the call as authors and lead authors, of which there are probably far too many of you to name, so apologies for that. So essentially, every time we update the MGD, it's an enormous effort that draws on the collective expertise of the GFY community. And the updates are based on, I guess, 2 things. Recently identified country needs for, I guess, new or updated or, I guess, additional guidance. And I guess the emergence of new methods and new approaches or new technologies which are deemed to be operational, so ready to be taken up by countries. But then, of course, every time we update the MGD, there are always going to be outstanding gaps and topics where more guidance is needed than, I guess, our current capabilities or our technical consensus allows for. And so in 2020, with the MGD3, the Geosecretariat kindly presented GFY with a series of proposals for rapid response modules to help fulfill some of these gaps, which were remaining after the publication of MGD3. And this is essentially the genesis of this workshop. And I guess additionally, GFY has long wanted to, I guess, provide greater assistance to countries on spatially explicit land use change estimates for greenhouse gas accounting and other purposes. And of course, be working to help partners, I guess, utilize the FAO's CFOL platform as a GFY resource and an operational environment to, I guess, support the uptake and disseminations of partners' tools that can be made available to help countries produce these estimates. The last thing I'll say is it's important to note that GFY doesn't pick winners. So there will be no, I guess, one tool to rule them all. If a tool is able to fulfill a recognized country need and is considered operational, GFY can help make them all available to countries in a fair and balanced framework, I guess, that allows countries to select which products best suits their own unique national needs. So we're looking at many different products today. We're not trying to pick a winner. If they're operational and able to fulfill country needs for data, then they can all be made available and we allow countries to choose. So I think that's an important note to end on. I'll leave it there. Again, thanks to Geo-Secretariat for organising this workshop, especially Sarah and Gilberto. Thanks also to Sandro for his involvement from the Ipcc, TFI, TSU, and of course to FAO for making CEPAL available, and to all the partners who are going to be demonstrating their products, and of course the reviewers as well. So thank you all very much, and looking forward to the discussions. You'll hear more from me later. Back to you, Sarah.
Thanks, Tom. Now I would like to give the floor to Julian Fox, team leader of National Forest Monitoring at FAO, for some additional remarks as a GFOI lead partner.
Thanks so much, Sarah. And I mean, just complimenting the great words of Gilberto and Thomas there. And also that I'm wearing two hats, maybe one hat as the GFOI lead representative for FAO, and the second hat has been operationally responsible for FAO's CEPAL project. I mean, speaking as a GFOI lead, this collaboration with Geo is really wonderful to see. And thanks, Gilberto, for pushing it forward. I mean, GFOI is really proud to be a flagship of Geo, and we continue to find new ways to deliver mutual benefits for both organizations and their partners. And we're super pleased to provide the CEPAL platform as a Geo and GFOI resource to demonstrate how partners' tools and methods can be used and moved from R&D, from development to application. And I'll talk a bit about that in a moment. Yeah, thanks to all the GFOI partners and the other experts that are here. It's an incredible collection of people. Ultimately, we hope we're able to progress some of the ideas discussed today into operational and accessible methods for countries to use in their national forest monitoring systems and associated MRV procedures. Speaking very quickly on behalf of FAO's CEPAL project, firstly, thank you to Norway's International Climate and Forest Initiative for the unwavering support. CEPAL started out as a pilot project 5 years ago. From its inception, it was really designed as a collaborative platform. We realized pretty quickly that it grew beyond a pilot phase, and it was really adopted by the countries, most importantly, to create really good geospatial data for their forest and land use. It lowers the barriers to access and process big data, and it really, from our side, we're a bit biased, but it provides a really fast route from experimentation, R&D, to publication, to application in the countries where we really want to land our innovations. And it enables people of different abilities to engage. If you're a developer or you're a novice, you can go into CEPAL and you can create really sophisticated products. From our side, we think that it keeps the user focused on the result, answering their question rather than spending a ton of time collecting data and setting up a processing. So contributing to CEPAL is a great way to get your data, methods, algorithms immediately used by a community of over 7,000 users, many of them country technicians in developing countries, which for us is so exciting and important. CEPAL is completely open source, and it has the backing of FAO, but it's really a collaborative platform. Already the platform has many users and is helping countries create geospatial data for reporting for REDD+. In fact, 70% of the 50 REDD+ submissions to the UNFCCC, the reference emission levels, have used CEPAL or other open forest tools. So as a final comment, it's really a collaborative platform for you, the monitoring and MRV community, and we encourage you to use it as needed. And we're extremely happy and delighted that Geo and GFOI have organized this wonderful workshop, and really looking forward to hearing some fantastic innovative solutions and supporting them from experimentation to application. Back to you, Sarah.
Thank you, Julian. Yeah, it's very exciting to be part of this process. And I'm now passing the floor to Lucia Perugini, who is a senior research manager at the Euro-Mediterranean Center on Climate Change Foundation, as well as an expert negotiator in the UNFCCC. But here she's in her capacity as co-chair of the Geo Climate Change Working Group. Lucia.
Thank you, Sarah. Thank you for the invitation. And we have been thrilled to organize this workshop. It's a very important step of the roadmap of this climate change working group under the GEO that has been established last year, that with the aim of develop and implement a comprehensive GEO climate change action strategy to advance the use of Earth observation in support of climate adaptation, but indeed also mitigation. The subgroup that I am honored to chair, that this is the subgroup of mitigation, aims to facilitate the improvement of targeted Earth observation data to assist countries with enhancing monitoring of their mitigation action under the Ipcc, but also and especially under the forthcoming obligation under the Paris Agreement. This workshop is it's a tremendous opportunity to advance in this work. It's one of the key milestones of our roadmap, because we have really the key actors here represented, and we should keep in mind that Ipcc, and thank for your participation in this FAO, and many developer of important and useful software. But what we really aim to do is to look forward, to look very focused on the forthcoming obligation under the enhanced transparency framework under the Paris Agreement, where all countries will need to report their greenhouse gases, including within the LULUCF and the photo sector in general, every 2 years. And this is a quite demanding effort that Annex 1 parties and developed countries have been doing since a long time. But also developing countries will enter into this very difficult and complex process. And I think that this process, the support of the FAO and the GEO and the Earth observation and the Ipcc here convened within this workshop is key, because anything that is constructed here needs to be coherent and compliant with the Ipcc guidelines to support effectively the reporting obligations. So I'm very happy. I want to take more time to the workshop, and I really wish a very fruitful discussion, and I really hope that this is just the beginning of a fruitful process to provide useful tools that will really serve practically developing countries. But not only, I just wanted to add a piece of information also. The EU, under the new LULUCF regulation, will need to report spatially explicit within the LULUCF. So it will be also a radical change, as the EU as well is not using spatially explicit data at the moment. Sometimes using mainly statistical data. So it will be a process we'll need to keep an eye on, also for improving all countries' inventories. Thank you very much, and I wish you all a nice 2 days workshop.
Thank you, Lucia. That's very, very interesting and insightful. These are the opening remarks, and I'd like to now open the scene setting session that prepares the ground for the demonstrations that will come after. Please note that the Q&A session will be held following the 4 presentations that are lined up. So again, please use the Q&A box to send your questions, and we will pick them up. The speakers will respond in writing as much as they can, or the moderators will use them for the discussion later. Right, so these presentations are part of the conversation, but also part of the solution. And I'm pleased to start with Sandro Federici, who's the head of Ipcc TFI Technical Support Unit, for an introduction to Ipcc Approach 3 and wall-to-wall method. Sandro, please.
Thank you, Sara. Thank you very much to you and to Gilberto for your willingness and efforts to make this meeting possible. We are going to do 2 presentations. Actually, the most important is the second one, which is not the one that I'm doing. But anyhow, yeah, I will say something about the land representation, because at the end, the subject of all this is the land representation, the main subject. The land representation made with approach 3 with the wall-to-wall method. We see that we have different approaches, and approach 3 may be implemented not just with wall-to-wall, but also with other approaches. I will say something on land categories, of course, I will define the land representation and then something on the wall-to-wall guidance that the Ipcc guidelines provide. I will be quite fast, so because I see the time is limited, I wish to leave more time for the second presentation. Anyhow, for questions, no any problem. So what is the land representation? Is in practice, a greenhouse gas inventory for all the land use categories is based on the area of this, the area, the set of area data is the land representation across time. This is very important, this concept of a timing. So it's not just a picture of your land use, of the land uses in your country at a certain date, but it's important to have a time series so to study the land use changes across time, because indeed the main hotspot of emissions and removals are the land use change areas. So is a key element of a greenhouse gas inventory for the AFOLU sector. Completeness and consistency are the two key and mutually linked elements. Land representation must be complete to give the full picture of what is occurring in your country. It should be consistent, otherwise it won't be completed because you will losing or gaining areas across time. So categories, land classification. Of course, land representation is based on categories. You classify your territory in some land categories. We have some land use, the Ipcc is based on land use categories. However, this category are actually a mix of land cover and land use elements. For instance, for the forest cover, the forest threshold is indeed a cover element. You classify a forest because it meets some physical threshold. Then you look at the use to better understand if it maybe can be a perennial cropland or is indeed a forest land. Then we'll see managed and unmanaged. Anyhow, the land cover elements are the basis to start for a classification. It's very important because it's according to the land cover elements that you may derive the carbon stock level of a country. So the trees, the presence of trees tell you a lot about the carbon stock of a land, of the biomass pool, of course. And the land use is a fundamental proxy for the expected dynamic. If I have an urban forest, even if there are trees, I expect a dynamic in the carbon pools, which is significantly different from that of a forest land. It is also significantly different from that of a perennial cropland plantation. So the use is a proxy for the expected dynamic, while the cover tell you a lot about the actual content of carbon of a land. Ipcc has 6 land categories. You see the list. Be aware that a greenhouse gas inventory must be made with these 6 land use categories. There is flexibility for countries to provide for definition of these categories, but the categories remains these. There is flexibility to go for subcategories, so substratification, but still the categories are those. And a greenhouse gas inventory, generally, the first level of stratification is about the history of the land in terms of use. So the land use categories are all split in 2 other categories. One that is called the forest land, remaining forest land, which is the category where you have land that did not change the use for a certain historical period. For Ipcc is 20 years this period. Countries have some flexibility to look for a longer period, even if usually is not so convenient because to make everything then comparable, consistent internally in the land representation, because you have different land use categories, and then comparable across countries, it can be a challenge. And then you have the land converted that in the last 20 years, the land was converted to one land use to another, or even may have been undergone some multiple changes. So this is like an algorithm of classification. We will look at the categorization of a land. First, looks at whether the physical threshold of a forest is met. For Ipcc, this is enough to classify a forest, a land as forest. Then we look then if the physical threshold are not met, it looks first whether it's a cropland, so it's subject to agricultural practices. Then whether it's a grassland, or if it doesn't meet any of these three categories, it looks whether it's a wetlands or a settlement. They are almost at the same hierarchical level, we may say. Finally, if a land doesn't meet any of those land use category, goes actually in the last category, that is other land. Other land is a category that is there to make the total area of the country classifiable under at least one category. And usually is with land that have no significant carbon stock, because if a land has trees, forest land, or I said, there could be a perennial crop, an urban forest. If it has other woody vegetation, is likely a grassland, or also could be a cropland, or could be in specific cases within a wetlands like mangroves or a settlement. If also if the land is covered by grasses, it can be a grassland, a cropland. So it goes in any of the other categories. When you don't have any of these elements, then you likely have another land, and this is the last in its level. This is a comparison of the land use categories, and then which are the land cover element and land use element that make the category classifiable. So a manager forest land should meet a forest threshold, of course, should meet any other definition the country has for forest. And a manager forest land, you see, this is a land category, has no any land use because it's unmanaged. What is enough is that the forest threshold is met, and so on. You will see anyhow for all the unmanaged categories, there is not a land use component. It's just the land cover that make the land classified. That's why it's so important. And that's why also the land, satellite remote sensing is so effective also in producing land use classification. Key elements, yeah, I said that can be further classified. Okay, for a land classification, you need to have rules. Rules according to which you classify a land. One, you have the definition, and then you need rules to be applied. You will see these rules can be applied. These are the various approaches. The rules can be applied at different level. And according with the level they are applied and the time series of data available, Ipcc elaborate three approaches. Approach one, you just have a total, is a picture. You have the land use classes, but you don't have any, any spatial reference, but you don't have also no time series reference. So it's just a picture of what, of a statistic, let's say, it's better to say, is a statistic of the area classification. Approach two has some spatial elements because allow you to identify whether a forest land has been converted to cropland, to grassland, or to any other land use classes. So approach two allow not only to have a picture of the actual current land uses, but also of what has been the history within 2 points on time only. Approach three allow you to track land use changes across an entire time series. So with approach three, you may actually track multiple land use changes. You see, approach three, according with the Ipcc guideline, can be sample based. We are not going to discuss this today. Survey based. We are also not going to discuss this today. Or wall to wall, which is the subject of this approach. Of course, anybody knows that the wall to wall is more informative because you have a full map of your country, which is what everybody desires. But there are also some challenges that we will be discussing, especially then when the representation is used for the greenhouse gas inventory. I will skip this. These are figures taken from the Ipcc guidelines. So now this is a visualization of an approach one. You have just the areas. This is a visualization of approach two, where you may have a matrix because you know which kind of land use initially here has been converted in whatever else. For instance, here you have forest land that has been converted to grassland, and so on, from between 2 points on time. And then you have approach 3. Sorry, this is the sampling approach. You just sample some point, and then you may extrapolate, you may scale this point to a map if you need, or just to use the sampling point for a statistic, to derive a statistical data to be used to build a land use a land representation, and then to use the land representation for the greenhouse gas inventory. Or you have wall-to-wall, you have maps, and then you do the you derive a land representation directly from the map. And this can be done either at pixel level, pixel by pixel, and you may track each single pixel and derive in practice a land representation for each pixel, or at the level of units of land, which means to aggregate those pixels that have a same land use and historical history of land use. So they are expected to have the same, under the same condition together, and then to produce a land representation at this level. Of course, in case you go for a unit of land, you may also, within 2 points on time, represent also the approach 3 with a matrix, an annual matrix. So this is again a Ipcc guideline. There are 2 broad wall-to-wall methods. One is to produce a consistent time series of data. So you do time series analysis, you produce a consistent land representation. The second, which is of course what you expect to do to have the best accuracy possible. The second is to use what is available in the country. The country has already some map. You use those maps that have been made with different sensor methods and so on to derive land use changes. Of course, in this case, you need to put a lot of care to avoid that technical differences, methodological differences in the 2 maps result in land use in reporting land use changes which never occur. So, beside the second approach is not, what is desirable. The countries are using, and is it perfectly, is better than nothing. When you do a greenhouse gas inventory, you must have a land representation, and you must do the representation with what you have available. Then you may also study, you should study how to improve it. But countries are currently still using maps, because to collect all the data, to do the land consistent time series for land representation, in many cases is seen. It is not Ipcc saying, but this is seen as technically difficult and resource intensive. I do have I guess that a better understanding of what should be done, and CEPAL can be a very important instrument, may show that this is not always the case, at least not always the case. A wall-to-wall approach has the big advantage that you may use a geographic information system for doing the data analysis. These are the good practice. This is a synthesis. This is not just the exact wording, because otherwise won't have been enough to have a slide of the most important good practices that are in the guide. Good practice usually are very generic, because need to be applicable always, just to guide. They don't prescribe the technical work, but they are aimed to guide the technical work. So ensure consistency is a must, not just because of Ipcc, because for a greenhouse gas inventory, then under UNFCCC, this is a principle, this is a requirement that must be met as far as everything as far as possible, because you will see is a greenhouse gas inventory is a continuous effort to improve it. A common projection, there is the problem of cloud cover, so minimize the impact that cloud cover may have, so in terms also of using different images at different time to build a map. Ensure that data are consistent with methods. Of course, you need to have data that allow you to extract the information needed for the method that you wish to apply for greenhouse gas inventories. Time series gap filling is a big issue, especially when countries are working in extrapolating. You know, a greenhouse gas inventory is a time series. It requires also data farther back to avoid that some artifact trend is built in the time series. This is a big challenge, especially for it's already a challenge for developed countries because they need to have a 1990, which may likely require data back to 70s, and the quality of the data, the availability data is not the same. So this is a big issue that you see in the greenhouse gas inventory of some countries, this artifact trend, because improving the sensor, improving also the timing of the image. Now you have a more frequent images as an impact in the detection of land use changes. Note that this, I mean, is there, everybody is aware, but also the gas inventory is the realm of what is possible to be done. Okay, this is challenges. Let me say which are the challenges and then what we will be stressing in the next presentation. Pixel attribution, how to go from the image signal to a land cover elements. And then how to aggregate or how to derive from land cover elements the land categories. As you've seen, there are, for instance, forest land has one threshold that is the minimum area. So how to go there. The identification land cover changes. The signal in terms of images may change for many other reasons which are not a land cover change. There is seasonality, there is variability, there is other more technical element. The attribution land cover changes also. You have a land cover change, but is this a land use change? Is the routine effect of a management practice, it is a disturbance or is a land use change? Okay, this is about errors. What I want to stress here is only this one. A very important thing that a greenhouse gas inventory compiler must have clear is the fact that a map, you may study the accuracy of a map, you may, for instance, with a confusion matrix, you may quantify any bias you have in the map, but the map remains there. Even if I quantify the bias, the map is there. And if I do use the map at the pixel level to do my greenhouse gas inventory, the bias remains there. And I need to deal with the bias in my greenhouse gas estimates. So this must be extremely clear. An alternative, which is what also we are trying to do with a tool, is to derive statistical data from the map and to adjust the statistical data. And that to use for the greenhouse gas inventory, not the map, but the statistical data derived from the map. This allows to get rid of the bias that a map may have. Sorry, and this is all. I guess almost I've been in the 50 minutes, and I've seen. My understanding or question is after, so I just stop sharing, and then Carly will go with the next presentation.
Thanks, Sandro. Yes, the questions will be for later, but you can already type the responses. You see you have questions for you in the Q&A box, and now I'm reminding all the participants that they can post their questions in between presentations. So I'm now giving the floor to Carly. Carly Green, consultant to the Ipcc TFI Technical Support Unit, who will speak to the ongoing work on the add-on for land representation of the Ipcc inventory software and all the related technical challenges and opportunities for cooperation. Over to you, Carly.
Thank you, Sarah. Can you can see my presentation? Yeah, cool. And thanks to Sandro for the introduction of the technical material from the guidelines. As Sarah said, I'm going to be talking to you about project that I'm working on with Sandro with the Ipcc TFI Technical Support Unit to develop an add-on to the Ipcc software for land representation. I'm going to cover the details of the technical specification, and as we go through, we've identified two opportunities for cooperation that we can discuss hopefully over the next couple of days. So the outline of my presentation is the Ipcc inventory software. I'm going to give you a bit of a background, the technical specification, as I said, and the two areas of opportunity for cooperation. So the Ipcc software was released in 2012, and its primary function is to assist inventory compilers to use the 2006 Ipcc guidelines to develop estimates for their reporting. It's built in Access for Windows operating systems, and it's freely available from the Ipcc website for countries to use. So the inventory software itself, it allows, as I said, the preparation of estimates of both emissions and removals from all Ipcc categories across all sectors of the national greenhouse gas inventory. Here, we're really interested in the AFLU sector at this workshop, and I'm going to be talking about this particular add-on, which is to support the AFLU sector. And in the Ipcc software, it produces estimates for this sector of both emissions and removals at the level of each unit of land. And so that can be from one to many. What it doesn't support is data collection, and this has been identified for some time as a critical gap for greenhouse gas compilers. And so this add-on is to try and help fill that gap.
Carly, sorry to interrupt. Your presentation is on the first slide, perhaps.
Is that better?
Yes.
Okay, so cool. So we're already up to slide 3. So this is awesome. We're flying. Sorry, everyone. So as I said, the add-on is to basically support this critical data gap that's been identified by inventory compilers. Basically the add-on is going to be used to enhance the usability of the software. And the key components of this new add-on is to support the data collection for land representation, to enable some optionality, so national sort of specifications where possible, and to facilitate the data upload directly into the Ipcc software. So we're planning to produce run the add-on on the CPL platform, and then have a data export capacity to import straight into the Access database. So the add-on will be, of course, voluntary and supplementary. So that means that the Ipcc software will still be able to operate as it is now. It's not going to be a requirement to use this this add-on, but of course it's available for those inventory compilers who are finding that data hard to collect for the AFLU sector. So as I said, and also as Sandra alluded to, there's these two methods really for producing activity data, one sampling methodology and the wall-to-wall methodology for approach 2 and 3 data. And I'm just going to be talking about the wall-to-wall methodology for the add-on, but we are producing 2, one each for the sampling and wall-to-wall methodologies. And so the one that I'm going to discuss is going to be based, well, the technical specification is being written at the moment to utilize the CPL platform, QGIS, and possibly some other tools to develop this land representation data set, import into the software, and then at the end, the intention is to produce emissions and removal estimates for the 6 land categories. So as I said, at the moment, we're in the technical specification stage, and really the technical specification has these 6 components. I'm going to talk through each one of these individually on the next few slides, so I won't dwell here too long, other than to say that some of these I guess elements of the technical specification are requiring some cooperation with some external parties for some gaps that we've identified. So the first thing in the tech spec is to basically the image analysis for the land classification, which we are planning to do on the SQL platform. Here we want to create an environment where users can infer data on land cover and land use through multispectral and multitemporal analysis. We hope to provide an algorithm for pixel classification of the land cover elements. And ideally, we want that to be done well, the image is classified for the 6 Ipcc land categories as Sandro outlined in his presentation to achieve approach 2 and approach 3 data sets. At the moment, we're still searching for an algorithm to actually classify these 6 land use categories. Oops, sorry. So this is one particular area of cooperation that we're hoping to work with people on, and so if anyone out there has one, give me a call. The second, I guess, task we're going to do is the land classification, again, in the SQL environment. Here, we will plan to provide logical rules to aggregate and classify the pixels according to the category definitions. Here in this environment, we'd like to have the addition so users can specify any sort of subcategories they have to make it more nationally specific. And of course, here we have to be able to enable the delineation of unmanaged lands to meet the guidelines reporting requirements. Third is the tracking of the land cover and changes through time. So we each pixel will be stratified based on its historical land use information. Again, with enabled options to stratify by national specific subcategories if necessary. User input options for the transition periods as well for each conversion type. As a default, the 20 years will be set, but of course, if you're applying a national methodology, that you can have different transition periods to enable you to calculate those legacy emissions. And then pixels to be aggregated in units of land to produce these annual matrices, and we're hoping to be able to produce those either as approach 2 or approach 3 coming out of the add-on to be able to be uploaded into the Ipcc software. As Sandro alluded to, we need to correct for bias or deal with bias. So the guidelines specify that we have to estimate and eliminate bias as far as can be judged is the terminology in the guidelines. We can assess this either through model-assisted generalized regression, which we have, which is included in the MGD as an option, but not really elaborated on the how to do that. So just keep that in mind as I work through this slide. And then also in the confusion matrix framework. So at the moment, we're not quite sure at this stage how we're going to approach that. Ideally, though, the methodology needs to lead to the production of bias-corrected statistics on land cover and land use and change, or the option to extract the data at that point and proceed with a different method for eliminating bias if the country has their own methodology. So at the moment, we're looking for cooperation, or potential option for cooperation here is to produce a compatible method for model-assisted generalized regression to estimate and eliminate bias as far as can be judged. And so this is something that we would welcome some assistance on. Gap filling, again, here we will provide an option to be built according to the new additional guidance in the 2019 refinement. So there's some more guidance there that we'll pull together to put to help countries enable them to help fill this the gaps in their time series in accordance with that guidelines. And then here, of course, we'll also have that option for countries who may also have their own method. So as you can see, we're trying to make it tailorable to produce national specific activity data wherever possible. And then the final element of the development will be to compile the land representation data set. And so this needs to be provided at each unit of land and exportable in a compatible format so that it can be directly uploaded into the software by compilers to complete the calculations of emissions removals there. So this add-on will produce the activity data that will then be uploaded into the software for the estimates of the emissions and removals. So just in summary, I know I probably flown through that pretty quick, but just a reminder that we are at the moment developing the technical specification in collaboration with FAO, both for Collect Earth and of course CEPAL, which is the one we've just gone through. The algorithm for the land classification on the six Ipcc land categories is still missing in action. So anyone out there with something to help us with that, that would be great to hear from you. And then of course some technical expertise around model assisted generalized regression would be really helpful as well, as we try to develop a tool to address and eliminate bias as far as can be judged and produce both approach 2 and approach 3 inputs into the software. And that is me. Thank you.
Thank you so much, Carly, especially for the input on potential collaborations based on your ongoing work. We will discuss that during the moderated discussion at the end of today. I would like now to introduce the next speaker. Oh, by the way, Carly, there are also questions for you in the Q&A box, so have a look at those. You can type the answer. Next speaker is Adam Lewis, leading the Geo Initiative Digital Earth Africa establishment team, who will present the current status and availability of FOLU data monitoring tools in Digital Earth Africa.
Thank you, Sarah. Hope everybody can hear me. Oh, hang on, I forgot to turn my camera on. Hang on.
You can see the presentation, but not you.
I'm sorry, I've left my camera off and I don't know how to get it on now.
Okay.
My klutz. Okay, I'm just going to go ahead and talk, and I apologize for my technical ineptitude. Oh, here we go. That might be better. Thank you for giving me the opportunity to be part of the workshop here. It's a real privilege to be in such great company and nice to see some friendly faces. I've got great admiration for all the work that's going on under GFOI. It's really amazing. I want to also acknowledge GEO. We're now for inviting us to this, and we're now an initiative of GEO. Digital Earth Africa became an initiative a couple of weeks ago, it seems. It might be longer. And we're really appreciative of the support that GEO has given to the program and continues to do so. When we talk about operational monitoring, spatially explicit, country-based, consistent, I hope that what you'll see in DE Africa is essentially opportunity. DE Africa is basically a platform. We're a platform of data and analytical tools. How exactly they fit together with CEPAL and GFOI, I'm not really sure yet, but and that's kind of for everybody else to work out. We're a platform of data for all of Africa, covering the entire continent. The data, this is a model, a little schematic for the data coming from Landsat. And as of this week, we have fully operational data flows of Landsat, Sentinel-1 and Sentinel-2 data coming to Africa in full resolution, being indexed into a data cube, available in Amazon S3 buckets and through web services, and updated daily for the largest continent on Earth at full resolution. So that's a pretty amazing achievement, and it covers, of course, more than 50 countries, and heck, there's got to be opportunity in there somewhere that relates to how we report on against global and international protocols. How are we going? In addition to that, all the data we have are processed to as close as you can get to CEOS analysis ready data for land. The Sentinel-2A and 2B are processed by ESA. Landsat Collection 2 is processed by the USGS, as you would know. Sentinel-1, we created a supply chain working with the Synergize company in Europe to produce that data set. ALOS comes from JAXA, of course. And that makes the data really a lot more exploitable than would otherwise be the case. And it's something I'm particularly pleased about. And of course, and this audience knows this, but that really gives us in one place the access to a whole range of surface measurements, from surface reflectance to anything we can derive from that, NDVIs or water indices or water quality indices, or the temperature data from Landsat instruments, or surface roughness from ALOS, the statistical annual variation of surface reflectance through the year. And just because it only arrived today, the normalized radar backscatter from Sentinel-1. So there is an incredibly rich data set here that is open and exploitable. And of course, it exists for all of Africa. So whatever country, that data, exactly the same data, can be available. That image itself is a testament to the data cube scale and the processing. So that particular image is a median image for 2020, and the reason that there is no clouds through most of the tropics, with a couple of fractional small exceptions, is that you're really integrating the clouds out as a time series to pull out the geometric median surface reflectance. And that itself becomes a very powerful product for further analysis. So the model here is essentially get the data. I'm not going to take 10 minutes, by the way. I should have warned you of that. We draw in the data, make sure it's analysis ready, get it to Africa in an operational data flow, and index it into a data cube, which I make sound fairly trivial, but for those people who actually work at doing that, they know how difficult it is to take a script that works once with one line and do it millions of times, and then to set up processes that automatically detect new imagery coming in and move that through the pipeline and bring it into the infrastructure. That's then indexed into the Open Data Cube, as I mentioned, and the purpose for that is to be able to target Sustainable Development Goals or any other challenges on the continent that might be, and particularly to identify with continental agendas encapsulated here by the Agenda 2063, the Africa we want. So, for example, those data sets are allowing us to produce continental products. Guided by African stakeholders, one of the continental products we're putting together is a crop mask. And that is a machine learning algorithm drawing on that full depth of data. And here it's showing that the yellow polygony type boundaries are for the Eastern African agroecological zone. And that's recently been rolled out to the West and North Africa. And the people doing it say that it's 10-meter resolution and it's pretty damned accurate. And the people doing it aren't sitting in Canberra so much as sitting in a range of organizations in Africa. And the reason they think it's accurate is that they've collected this reference data to train the models and to test them. And so we have a validation task team, which has now become a validation and product development task team, which distributes this work across our African partner institutions. And of course, you will have doubtless have heard of water observations from space, which is a surface mapping of water across Africa. And it's a case of taking an algorithm and operationalizing it at scale for whole continents. As important as the data are the partnerships behind this. So we have partnerships, certainly with our funding partners. We have partnerships and whatever it is that GEO bring, it's support, I guess, international connections. We have partnerships with a range of African institutes, as well as with corporates like Esri and Amazon Web Services in their not-for-profit areas. And those partnerships include a range of African institutes who bring presence in Africa, and that presence isn't in single countries. Groups like Agromet and Afrigist have a mandate to work across regions of Africa, and as do OSS and RCMRD. So these institutes give us reach to country level applications across Africa, and that's further bolstered by our governing committees, particularly members of our technical advisory committee, who range from, once we bring them in, from Tunisia to Madagascar. That's important because that's about ownership. They're driving a growing user community. We have, and the simplest metric on this is in the bottom right, which is that from June 2020 to, it's almost 12 months now, we've gone from close to 0 actual users of the sort of sandbox environment for this capability to well over 700. And then there are various other interfaces that people are using. The reason that's important is it's demonstrating appetite for the data and for tools to work with the data. However, the data aren't restricted to our interfaces. The data can be accessed through an Esri interface or through any other software interface that wishes to tap into those open web services or into the Amazon S3 buckets. Most importantly, what we're bringing is ownership. So there's a real sense of, our vision is that this be a routine, reliable and operational service. That vision wasn't developed by me. That vision was developed by people in Africa, such as you can see here. And we're now in the process, within a couple of weeks, I think we'll make an announcement of who will host the program management office, this big box in the middle of this governance diagram. We have a very well-established technical advisory committee, which is chaired by 2 people in Africa, in South Africa and Ghana, and populated by a whole range of individuals with expertise, and we'll soon be convening our governing board, which is a very high-level group that will provide strategic guidance and, importantly, very high-level country buy-in, as well as buy-in from the African Union Commission into the capability. That sense of it being led and owned by African countries and Africans in general is quite vital to uptake. And we see opportunities coming out of this already. Developing countries and even not so developed countries really want and need to take ownership of national assessment and reporting. And I say that because that's the conversation that happens more and more regularly now that Digital Earth Africa is operational, as recently as a few hours ago in a meeting I had earlier this evening. What we're providing with DE Africa is an African-owned capability to take that thinking forward, and opportunities exist to port methods onto DE Africa as an operational platform that can be exploited at scale. And indeed, we're exploring the one such opportunity with the FAO, working on land cover, where they've developed a land cover model and mapping system for Lesotho, and want to look at how that can be ported onto this infrastructure. And in looking at that, our mind goes to how could that then be expanded across other countries. And I mentioned leadership from places like Rwanda and Ghana and South Africa and Tanzania, simply because they're the ones that have come to front of mind in the last 5 to 10 working days, where there's been explicit conversations about how could they get involved in international reporting using Digital Earth Africa as a platform. So there's an appetite for engagement in these international reporting regimes, and there is a strong sense of this has to be done by us as countries. We want to step up to do this. And that's exemplified by the Ghana Parliamentary Data Fair on the right there, which is an example of the desire for parliaments. This is, presidential and parliamentary majority parties calling for a data fair to look at how they can use data and information more effectively and what they need to do to engage with it. There is an amazing appetite for countries to engage with this data. And that's the last thing I wanted to say, Sarah. Thank you. So I'll throw it over to the next speaker now.
Thanks, Adam. It's really great to hear about all these developments and the ambition. And ideally, this workshop will discuss tools that are available or will become available in CIPA that could also become available for Digital Earth Africa. There are a couple of questions for you in the Q&A box. If you want to have a look at them, maybe type the answer or we will take them up later. And to complete the picture, I'd like to give the floor to Laura Duncanson from University of Maryland, who is co-leading the new geo-community activity GeoTrees, and will present the state of the art on biomass data availability for greenhouse gas emission estimates.
Thank you, Sarah. Can you see my slide okay? Maybe not. Can you see my slide okay?
Yeah, we can see them.
Yeah, okay. Sorry, I have a slight Wi-Fi connection issue, so hopefully this will go okay. But yeah, thank you so much for the invitation to participate. It is a great honor and privilege. So I'm here representing the Earth Observation of Forest Structure community. So I'm going to be talking about mapping above ground biomass from space with some new missions. So this is on behalf of course, a wide community of co-authors. So I'm going to sort of start with the punchline that we're in a very, very exciting moment in the remote sensing of forest structure and biomass. We have never before now had a satellite mission specifically designed for forest structure. And so NASA's GEDI, the Global Ecosystem Dynamics Investigation, which is a satellite LiDAR, it's the first LiDAR designed specifically for measuring forest height and structure. We've used other data sets in the past, borrowed from the ice community, but this is sort of the forest community's first dedicated mission. And so we have products from NASA's GEDI that are already online, elevation, canopy height, and canopy cover. But what I'm focused on today is above ground woody biomass, which is on the right here. So these maps are not yet released, but they are coming in the next few months. So it's a really exciting time for getting some of these data sets out. And we're really hoping that these get uptaken by many users, including GFOI members. So I wanted to quickly show what this mission's all about for those of you who aren't familiar with satellite LiDAR or GEDI. So GEDI's on the International Space Station, and it's about a refrigerator-sized box plugged into the ISS that shoots down near-infrared lasers. And the reflection from those lasers gives you a measurement of canopy height, of ground elevation under the forest, and we turn them into estimates of biomass. It's not a wall-to-wall mission like a Landsat or a MODIS or SAR data. It's a sample mission. And you can sort of think about it like you're taking forest inventory plot measurements from space. So each laser illuminates about a 25-meter diameter circle. And then from that, we estimate, as I said, canopy height, ground elevation, and very importantly, above ground biomass. And so we do this with billions of these shots across the world. So you have the systematic sampling of forest structure for every country up to 52 degrees latitude, because the ISS doesn't go over the poles, but it gives you billions of these consistent measurements. So we're really hoping that this will be a sort of a revolutionary moment where we can have this consistent forest structure and biomass information to provide to countries. So one of the main things we do is turn these orange squiggles here are LiDAR waveforms, and this is like a cross-sectional profile of a forest. So it's about an inventory plot, and we have to turn them into estimates of biomass. And so GEDI, like every other satellite mission, is not directly measuring biomass. We use the data to estimate biomass, which of course has uncertainty. And so we train empirical models using field plots, traditional field plots, and airborne LiDAR. For all of the sites on this map here, this is where we have training data. So you can see right away that there are many places on the globe where we have little to no training data. And of course, our empirical models are only as good as the data to train them. So we have a lot of data, but we don't have sufficient data. And of course, this data is going to, for many missions, go stale over time. So if you do happen to have field plot and airborne LiDAR data and you would like to work with the JEDI mission, please do get in touch. We're hoping to improve our algorithms and our models through time. The JEDI footprint level, so like that, the individual plot biomass products, those are going to be coming online any day now. So this is a very timely presentation. We're expecting them to come out literally any day. I wanted to also highlight that there are other data sources. So I'm on the JEDI science team, but there are many other EO data sources for forest structure and biomass estimation. One I'm particularly highlighting here because it is also collecting LiDAR data from space at the same time as JEDI is NASA's ICESat-2. It's a different LiDAR system designed primarily for the ice community, but we're again borrowing a little bit of data to fill JEDI's northern data gap north of 52 degrees latitude, but also this data is increasingly useful in low biomass systems like savannas and woodlands. And so there's a lot of exciting research to use ICESat-2 data also for a complementary data stream to JEDI. So we've got some products from ICESat-2 coming out as well. Now, I'm a LiDAR remote sensing scientist, but there's a lot of other data coming online, new and forthcoming missions, particularly on the SAR side. So a lot of the time, the LiDAR data is actually used as training data to wall-to-wall mapping with optical or radar data. So this really is an exciting moment in the EO forest structure because we have more data than ever before. But of course, with all that data come some challenges. So we have our JEDI product, which will be at a 1 kilometer resolution. We have ICESat-2 products that we're using with Landsat to make 30-meter maps. We have all sorts of different flavors of radar SAR data that can be used to make maps at different time scales, at different spatial resolutions. And as a community, really the fusion products we're anticipating will be the best of the bunch. So rather than just a JEDI data product, probably combining JEDI, ICESat-2, NASA ISRO's NISAR, ESA's upcoming P-band SAR mission Biomass, we're thinking we're going to get better and better over time. But we're also going to have more and more data products come out over time, which can certainly cause a lot of confusion within the EO community and certainly by people using the products. So that's what we want to reduce. And we've recently published a good practice guidance document, the CIOS LPV biomass protocol, to try to reduce some of this confusion, both within the EO community and by product users, which is really, it's like a large white paper summary of the state of knowledge of how to make a biomass map and how to validate it. And so I just wanted to quickly highlight for this community, we have two kind of new activities where we're trying to bring this biomass protocol to life. So this guidance document has then led to the new GeoActivity GeoTrees, which is proposing the establishment of a global forest biomass reference system. And so this is an acknowledgement of that issue that the EO community has when we're building our biomass products. We don't have enough training data, but then also very importantly, when we're trying to validate these products so that a user trying to use these products for emission factors estimation, if they are given 10 different products and the way that the uncertainty for each of them is calculated differently, it may lead to using none of the EO biomass products at all. So if we have this publicly available, globally representative validation reference network that's kept up to date through time, we will always know which of the products are best for which user community and hopefully help guide improvement in the products and increased uptake. I wanted to also highlight a very new activity that's in this biomass domain. So specifically for the UNFCCC's global stocktake in 2023, we're hoping that the EO biomass products are included in the mix. But in the appreciation that NASA's JEDI product is not the only one, CCI Biomass has a suite of biomass products as well, with a totally different approach to building their products. Sasan Sachi's group at JPL also has a suite of biomass products. So we're trying to get the EO community together and actually compare very transparently using open data and open tools which biomass products are better potentially for policy applications, and how we can combine the strengths of each biomass product together to produce one biomass product for policy applications. So this is a brand new activity that's just started a few months ago, but these are some of the candidate products here that we're comparing with available reference data, in acknowledgement that hopefully GeoTrees will provide improved reference data and much more in the future. We're taking what we have today and hopefully we'll be producing a product that people can use with a lot of confidence and transparency into the strengths and weaknesses of it. A huge part of this is the open science factor, and I'm really happy to be participating in a CEPAL event. I do think that the remote sensing of biomass community is also moving toward this sort of transparency and open science. And the biomass harmonization activity is actually being done on an open science platform, which is a bilaterally developed platform called the Multi-Mission Algorithm and Analysis Platform, or the MAP, which is a platform really designed for EO experts, but any product. So this is all based in Amazon Web Services and really focused right now on active remote sensing missions. And so currently it's hosting JEDI and ISAT-2, but in the future it'll host a lot of SAR missions like MESAR and ESA Biomass. And the idea here is when you make a biomass product on a platform like this, when the biomass product comes online, so does all of the source code. So everybody can see how each product was made. And indeed, if they want to, they can reproduce that product over their area of interest. So our biomass harmonization activity is being done on this so that when we have our harmonized product, everyone will know how we compared and harmonized that product. So this is all very new, but I do think that it reflects the transition in our community toward open science, which of course is the CEPAL approach as well. So it'll be interesting to see how we can hopefully get some of these biomass products linked to the CEPAL platform, and with the ultimate goal of increasing uptake. So that's all I had. Thank you so much again for the opportunity to talk to you, and I'll end there.
Perfect. Thank you, Laura. This is super exciting, and we're happy to have you and the rest of the team now as part of the Geo work program. This was the last presentation for this session. There are a couple of questions for you in the Q&A box, but I'm now inviting Tom Harvey to open the Q&A session. We have maybe 10 minutes for that because we were running a bit late, but we'll still be able to take some of the questions. So Tom.
Excellent. Thank you, Sarah, and thank you to all of our presenters for setting the scene so nicely. There's quite a bit to digest there, which is always, I think, useful at the beginning of a workshop like this, and I'm very pleased to see a lot of the questions being answered in the Q&A box already. That's what it's there for. So now we have a little over 10 minutes, we're going to say, for, I guess, some spoken answers from our presenters, and then following that, we're going to have a quick 10-minute break. So I will do my best to try and pull out what I think are some of the interesting points that have been raised. Apologies if written answers have already been put to these, but some I do want to draw the group's attention to. Firstly, I want to just raise, I guess, an overarching question, which, Sandro, this may be one for you, or it may be one possibly for Maria Jose Sanchez as the chair of the MGD advisory group, or perhaps some of our FAO colleagues. But I think an overarching question, which is useful to ask at the beginning, is why would a country want to go for approach 3 as opposed to approach 2? What are, I guess, some of the benefits? Obviously, we know there's going to be more detail and perhaps better results, but what can a country do with that, I guess, more detailed approach 3 information as opposed to approach 2? So I'll put that one out there for someone to potentially answer. Sandra, I'm not sure if you want to answer that, but in addition, I just wanted to... Yeah, please go.
I may say, well, approach 3 has a finer spatial and temporal resolution. This makes the estimate more accurate. So especially for mitigation action, I guess a country wish to have If you want to measure the actual impact of your mitigation action, you need to go for likely for approach 3. Approach 2, it depends, may and may not. It depends. But approach 3 for sure give you the best possible estimate. So
Absolutely.
this is why it's preferable.
Yeah, and I think that's a really good point to make, myself included, but I think our community does tend to think that the end game is simply reporting, but we need to remind ourselves that the purpose of reporting is to drive change. It is to drive mitigation and the reduction of emissions. So I guess having more detailed estimates better enables mitigation actions to occur. So that is something to keep at the forefront of our minds. Sandra, I also just wanted to ask, draw your attention to the first question raised by Frank Martin about where would you put mangroves. I realise this is quite a common question, but I think it's quite useful in terms of sort of thresholding, as you spoke about in your presentation. So I just wanted to ask if you could provide a quick summary of the typed answer that you've given here about how a country would deal with mangroves.
Yeah, in general, what is important at the end are those elements and the dynamic that you expect in the elements cover. Those that need to drive you in selecting the most appropriate methods. For a mangrove that meet the forest definition, is the biomass stock there that is the main driver of emissions removals. So the most appropriate equation are those in forest land. Wetlands are not the specific equation for biomass, because generally in wetlands you don't consider the biomass the most relevant pool. This is a kind of system that has relevant pools, relevant carbon stock in pools that are characteristic of forest land, which is the biomass especially, but also in those that are characteristic of other land uses like wetland, which is the soil. So the best way to go in these cases is to anyhow use the most appropriate methods, even if taken from another land category. If I classify mangrove forest as a forest land, which is what I expect doing, anyhow, for the soil, the most appropriate source of information can be the wetland supplement in this case, because that there is you have the methods more appropriate to estimate emissions removals in this characteristic type of land. So you need to be very pragmatic. Don't lose too much time about because I mean you may classify wetlands, but then you need to apply for the biomass the forest equation. Otherwise, you don't estimate properly, and vice versa. So you need to be pragmatic and simple. I know that countries spend a lot of time in these definitional issues, but often maybe they are not so important at the end, so far as then you use the right methodology for dealing with the biomass, for the carbon stock changes in the various pools. That's my pragmatic answer.
Excellent. Thanks, Sandro. I wholeheartedly agree. I think pragmatism is key to much of this. So thank you very much. Moving on to your colleague, Carly. Carly, I just wanted to ask you to perhaps summarise, again, your written answer here to the question from Laron about bias correction. Do you consider spatial bias, not only statistical, and propose GIS correction options or otherwise? Would you mind just giving a quick summary of your answer there of where you're up to and where you're thinking of going with this?
Thanks, Tom. So I guess where Sandro and I are up to and is that we're starting to, well, we're currently writing the technical specification, and we're looking for experts in this area to help us to, I guess, select the most appropriate way forward in this space. So we're basically drawing on some of the guidance in the MGD at the moment. And then we are hoping to, I guess, produce a method for addressing bias for approach 3 and approach 2 data on the platform. So I guess the short answer is I don't have a solution at the moment, and if anyone out there is interested in collaborating on that, we'd be would welcome that.
Excellent. Thank you, Carly. So consider that a call to arms. If anybody's interested there, please feel free to reach out to Carly, or if you haven't got her details, to contact us as the organisers.
Sandro, yeah, or Sandro.
Or Sandro.
Yeah.
Of course, yep. We can put you in touch if you don't have their details. Thank you very much, Carly. About 6 minutes left, so I might move on so we can make sure we get to all of the speakers. Thanks to Ipcc colleagues. Adam, there was a question for you, I think from Jose, about can we propose a classification model for our country in Digital Earth Africa?
Thanks, Tom. Thanks, Jose. Now, I don't know where Jose's from, actually, but the way in which we're working as a capability is that we'll work with anybody, essentially. So the platform is there. People can access the data and apply classifications and use the sandbox tools, which are free and open to test those classifications. But we're not providing a specialist service to do that. So countries which are that we're working with will build technical expertise, partly through our capacity development program in the data cube, in how to use those tools, and then would deploy those classifications themselves, or a group like FAO might deploy a classification working with us. In working with others, one of the things we have a mind to is what's the sustainability of the platform and the model for that. And so as we get more and more partners coming, looking to work on that platform, we're going to be asking them to help to sustain it as well, and likewise with countries. So I hope that answers the question a little bit, Tom.
Excellent. Thanks, Adam. I think you've done a nice job there. Can I just ask another question of you, Adam? Why Africa? And I guess, is this potentially applicable for other regions as well? What's the rationale behind the regional scope of Africa?
The rationale behind the regional scope is that it's just much better value for money. And the continental idea came from Australia. Let's do a whole continent. Africa is a much bigger continent and more difficult. But in doing, the data are captured universally around the globe. They're not captured country by country. Continents are logical geographical units to work with the EO data. And if we can capture and make available all the data for the whole continent, then 54 or 5 countries rather than one can make use of those data. So the opportunities to leverage the data for a wide range of purposes is amplified. And I should mention that can be through countries, through governments, or through NGOs, or through academics, or the private sector. So any actor in these systems can actually interact with and leverage the data. It then sets a model, we hope, through GEO, and this is one of the things that I think is of interest to GEO, is that might set a model for other continents or areas, and there's active interest in the Pacific and then potentially South America for the same sort of model.
Excellent. Thanks, Adam. That certainly makes sense to me. And so moving on now to Laura. Thanks, Laura, for your presentation. There's a question here from Wagner talking about, given that JEDI measures canopy height, would it be possible to monitor crop growing cycles, measuring their height, such as corn, or is it specifically designed for forest measurement? I think that's a useful point to clarify.
Yeah, no, thank you very much for the question. Unfortunately, this really is more forest focused. For most crops, the crop height signal will be blended into the ground. And because JEDI doesn't have the kind of systematic repeat that you would get from an optical or a SAR sensor, it's sort of this fairly random sample of stock. To monitor changes will be challenging. So you'll have to do some kind of data fusion to try to answer a question like that. But I think that JEDI is really not designed for that, unfortunately.
Excellent. Thanks, Laura. That's very useful to clarify. Okay, so we are nearly out of time. I just wanted to, sorry, Maria Jose Sanchez, to put you on the spot, but just wanted to see if you had any points about my opening question re the benefits of approach 3 over approach 2, or are you in furious agreement with Sandro's response to this? If you're with us, Maria. She might not be. She might have already taken the break, which is fine. We can draw her attention to that one a little bit later. So that is more than okay. I think we're just about out of time for the Q&A now.
It was my computer, Tom, that doesn't work very well. I'll try to switch the camera also. No, my point is that while working with countries and doing reviews, what ends up always with very important is how they consider the certification. And how the certification also conditions if they can really detect what they want to detect, which is the result of the activities and the actions that they do. And I was wondering if Sandro and Carly are taking this on board when they look into the add-on for approach 3. So how, if there's any guidance on the certification that can be put there, or if they consider it something more general and it's already covered by Ipcc.
No. We will allow countries to have any strata. They need to build the strata. I mean, this is linked to the software. In the software, you may build as many land use subdivision you wish. There is no limit, and accordingly, you may have as many as land substrata you wish to have into the tool that we will do. Of course, these add a lot of complexity. The problem here always is the balance between complexity and accuracy. Sometimes the complexity may trigger a problem of accuracy if it's not well managed. But yeah, the tool will allow as the software.
Excellent. Thank you, Sandro, and thank you, Maria. We could probably go on that topic for a little while, but we've already reduced our break considerably. I think we now only have 9 minutes. So thank you, everybody, for joining us thus far. Okay, so let's get started again. I hope you all refreshed your coffee cups or whatever it is, whatever your refreshment of choice is. That was a very good kickoff to the workshop before the break. Very useful to, I guess, set the scene with some of those contextual issues. But now this is where the rubber hits the road, if you will. This is where we will be actually looking at some of the software demonstrations. So we have a series of demonstrations happening here, similar to how we did before. We'll be alternating each time. However, please do feel free to continue asking questions throughout. For these sessions, we will be having a short Q&A for any burning clarifications or questions you may have after each presentation. So please do pop them in the Q&A as your questions come to mind. If we don't catch them immediately afterwards, the presenters will do their best to type written responses. So it is now my pleasure to introduce Eric Lindquist, and I believe he may be accompanied by Remy, I hope, and who will be introducing the CEPAL platform, which is obviously the environment where the subsequent demonstrations will be taking place or linked to. So over to you, Eric. And Remy.
Great. Thanks, Tom. You can hear me, I hope. Yeah.
Perfectly.
Great. Let me see if I can share my screen as we practiced. So many variables. There we go. Present. There we go. Okay, great. Thanks, everybody. Thank you so much. Good evening, good morning, good afternoon to everybody. I'm a bit overwhelmed by this whole thing, actually, but it's really a thrill to be here. And yeah, it's just a pleasure to be able to see all your names, to see some of your faces. I hope everybody's doing well in these still crazy times. I'm going to present to you about our platform that we've developed here called CEPAL. It's a short acronym for a long bunch of words, System for Earth Observation Data Access, Processing, and Analysis land monitoring. I have to be honest here and say that we came up with the acronym first and then tried to fill in the words around it, but just so it kind of worked out, because this is a sepal as well. It's an actual biological part of a flower. And this is a sepal. And today I'm going to talk to you about the second kind. But I wanted to just point out that it is biologically, it's based in biology. Laura already mentioned this. Oh, sorry, maybe I should get this. I don't know if you can see that or not. But anyway, Laura already mentioned this. It's a really good time to be an Earth observation scientist or a lover of Earth observation. We've never had so much data at hand, and we've never had so many tools and so much compute power to use these data. It doesn't change the challenge that we have, which is to still make the best use of the data that are available. Don't let pixels go to waste, right? No pixel left behind, as some of my colleagues used to like to say, but it is still a challenge. And so our charge is to make these data available, make them easy to use, easy to access, and get the decision making in the hands of the people that really should be making those decisions. So we built sepal with the objective of improving data access, processing, and the delivery of especially satellite data or remote sensing information. Both the data and the products to enable autonomous land monitoring capacity. And the key word there is autonomous. We want people to be able to do this themselves, where these decisions need to be taken. So I'm just going to talk really functional about the platform, some technical details about it, what are our high-level goals, and some really nitty-gritty details about how it actually functions, and not show very many like pretty slides. So I hope that's okay with people. I figured that might be what is of interest to this group. So our high-level goals with sepal are, as I said before, to create to be a cloud-based catalyst for autonomous land monitoring and data processing. So, sepal doesn't, like, I don't process data for you. FAO doesn't process data for you. Nobody processes data for you, but the tools are there for you to create, for access to the data you need and create the results and information that you want to create. In a sense, it's an effort to democratize access to these data that are so important and powerful, to democratize access to the algorithms needed to process the data, the methods and workflows that are used, and then of course to democratize the generation of results to anybody that wants to make results. We want to make computer code that is behind all of these algorithms and methods. We want to make that code actionable, and I'm not sure I'm using actionable correctly there, but we want to make code work and run and be useful for people. We want to help speed the time it takes from an innovation or a good idea to adoption in an operational sense. We want to make that time as little as possible, so that all those good ideas get implemented as fast as they can and get spread as quickly as they can. And ultimately, we want the platform to become a global public good for doing these sorts of things everywhere. So the basics of the sepal platform: it is completely open source. All of our code is accessible and free to do whatever you'd like to with it on GitHub. It allows easy query access and processing of Earth observation data at its most basic level. It's expandable with user scripts, so those scripts can be written in any programming language really, but Python, Google Earth Engine, R, C++, Bash, etc. And the goal obviously is to enable easy access processing to or of analysis ready data, lower the barrier of access to supercomputing, or at least high performance computing power, and then eliminate the trouble that's associated often with maintaining open source software via the normal maintenance and the dependencies that are required to update. We want to take that, get rid of all of those barriers to what have traditionally been difficulties in accessing and using open source data and processing algorithms. At the moment, as of this morning, the CEPAL platform has about 7,000 global active users. It's 6,955 when I last checked this morning. You can access the platform from anywhere in the world with internet or mobile phone. We have 3 language versions available right now. It's English, French, and Spanish, and we're working on more. You can create and process data in multiple formats. We do rely heavily on Google Earth Engine to do a lot of this, but you know, DataCube, basically any format that data comes in, we can access it and process it. And of course, then it's all combined. The bulk of it is contained behind a user interface that is seamless for front-end users. It's also able to deal with if you design interface, let's say using Python, we can accept that and make that run as well inside the platform. And as Julian mentioned earlier, today we want users to really focus on the task at hand and not necessarily data wrangling. Although if you want to be a data wrangler, we also support that. And then of course, we're really pretty agnostic when it comes to branding. I don't care about the brand. I just want, like I said, we want good ideas to be out there and used in all the contexts. This is a schematic of how the CEPAL system, how the entire platform more or less works. I don't need to go into too much detail about this, I don't think, but just to say that the user, the little stick figure there, logs into CEPAL, the main CEPAL instance that's running 24 hours a day, 7 days a week. Through that interface, you can access also your own personal cloud-based computer that is started when you want to start it and shut off when you want to shut it off. And all of the data is stored. So every CEPAL user gets a workspace, and that all of those data are stored and persistent in a Amazon file system at the moment. So this all sits on Amazon at the moment, but of course it could go to any managed file system. Managed server system rather, sorry. So it's a compute platform for big geospatial data analysis. Like I said, it's established sitting right now in the AWS ecosystem. It's an EFS storage system, which is persistent. So your data doesn't disappear unless you delete it. And it's always associated with your username. It's attached to AWS instances that can be provisioned for processing data by anyone, anywhere. And you have instantaneous access to computers ranging from 1 to 128 CPUs with 1 to 2,000 megabytes of RAM. And then we also have access to GPU machines as well. If you start up one of those machines in the AWS ecosystem, you'll be running on an Ubuntu Linux operating system. We have access to a number of open source programming tools and programming languages within that operating system. We rely heavily on the Earth Engine API, but we also run and enable access to R, Python, Bash, Perl, if anybody writes in Perl. Is one of my favorites, but C++, etc. And then we wrap that all, of course, in an easy to use interface, enabling all levels of engagement from novice to very advanced. Some integration that we've already been doing with the CEPAL platform include the integration of the BFAST algorithm, which Remy will demonstrate in the next presentation. We also have integrated the CCDC algorithm into our main interface. We've been working with the World Bank and to integrate the SMFM toolkit, which right now the satellite, I can't remember what the acronym stands for, but anyway, it's there and you can go there. We've integrated working with the JRC to integrate Guido's workbench, the Guido's toolbox workbench for fragmentation analyses. The Python soil moisture modeling for creating and analyzing changes in soil moisture over time. We work with Planet to integrate the Planet API or the Planet Data and Orders API so that users can download and access the newly freely available Norwegian, the NICFI Planet data direct through CEPAL. We work with JRC to integrate their moist forest product and work with them about that. And then we've also integrated some code directly from the SAR handbook from Severe Global to process SAR data. So these are just some examples of how we've been able to integrate code that isn't ours, stuff that isn't ours, and try to make it accessible and just runnable by anybody who logs into the CEPL platform. I have to thank our collaborators tremendously. We've been a project funded by NICFI for a long time, but we've been working with so many other groups and have received in-kind support at the very least from many other groups. And it's a truly collaborative platform, and that's really what we're trying to create with this. So just a few quick take-home messages. As I think I've probably said already many times, it's designed from the start to be an open source collaborative platform. We want to engage at the platform. With the platform, you can engage on any level, from novice to expert. The work you do on the CEPL platform is your own. It won't do anything by itself. It needs you to make it do stuff. So whatever you do is your own, and it should be used as such. We don't take credit for anything you do. It's all for you to do, and you to take credit for what you do with it. And things just run, and they can do so on very large machines. So we tried very hard to keep code that more or less always works, and keep that updated, and just enable the running of it. You can develop, if you're interested in developing things to share with CEPL or to run on CEPL, you can develop inside the platform or outside the platform. And once it's at a mature enough stage, we can share it with all CEPL users worldwide and enable it to run on the platform where people can actually do stuff with the code. It can. The nice thing also about CEPL is it's not by itself. It's code that can run inside the platform or outside of the platform. Pretty much all of it can run inside or outside CEPL. We just kind of wrap it and make it easier for you to do things inside the platform. But if the platform were to go away, all the code it could still be run wherever you wanted to run it. We feel that say like, even if you don't like the name or whatever of the platform, the concept is a repeatable concept. It's scalable and it's copyable. So like the theory of how we're doing things with the platform, I think, is something that can be always available. And finally, I mean, we created it honestly to do good. It's there to do that good. So please go ahead and take advantage of it, and ask us any questions you want at any time. Some quick references for your information. Our website, you can just go to cepl.io and sign up, and then some documentation. You can find our documentation online, the code on the GitHub site, and some other information about Open Forest, which is where this came from in the beginning. And these are the thanks to everybody. Well, these are thanks to people, but I should thank many more as well. But thanks to all those people. I have some examples here. I'm not going to go through them. I'm going to leave those for when the presentations are shared later, and they will be available in the shared presentation. So with that, thank you very much for your attention.
Excellent. Thank you so much, Eric, for that very useful overview. A couple of points that stood out for me was you talked about CEPL as a global common good, global public good might have been the language that you used, and you're seeking to democratize access to data, algorithms, methods, and results generation. I think that's very important to note, and I hope that this workshop will be able to demonstrate both of those points. So. So is the plan now that is Remy going to cover the BFAST demonstration? Is that right? Or Remy, did you have a separate presentation to complement what Eric just said?
Yeah, let me just say, so yeah, we worked with Jan Verbesselt at Wageningen, and so Jan is here on participating in the meeting, but Remy will do the BFAST presentation, or the demonstration of how BFAST runs in CEPL and how we use it operationally.
Excellent. Thanks, Eric. Over to you, Remy, for our first demonstration. Take it away.
All right, hitting the rubber for good now. Okay, I share the emotion that Eric was sharing earlier. I think it's a really great opportunity for us to demo. So let's go for it and try to make it run. Okay. I hope you can see my screen. I guess you do. Okay, as Eric mentioned, the only entry point to Sepal is actually to log into Sepal, and you go to sepal.io, and when you subscribe, you get a logon and a password. And the first thing you will get into when you land on is this page where you have the process page that directly links to the Google Earth engine API, and when you can create recipes. What we will demo shortly today is what we have implemented to process data with the BFAST time series algorithm developed by Wageningen University and Jans. Everything I'm going to be saying is pretty much summarized in our read the docs page on the BFAST GPU. So feel free to refer to it whenever. Right. So just a couple of words. The way we have set up that process is really making the link between Google Earth Engine to provide and retrieve the data and retrieve the time series, and local implementation using Python and actually using GPU processing for massive parallelization in order to process those huge data sets in a reasonable time set. So we're gonna very quickly demo both slides, how you get the data and how you process it. I'm going to be using material from a project we have ongoing, which is really on the operational side, of mapping deforestation, degradation, and assessing drivers. I will take the opportunity to share that link with you in the chat in case you want to follow, in case you want to see everything I'm going to be using in terms of material in this short demo is available on that page. It's a project in Central Africa, 6 countries targeted, so like 500 million hectares, all Francophone except Equatorial Guinea, which is Spanish. But all the material we are preparing for that project, which is really focusing on using Sepal for mapping deforestation degradation and using the open forest tools to monitor the drivers behind, you will find under the database tab, and inside here you will find a couple of assets that I'm going to be using for the demo. Right, so what I suggest we do today is this is where you land, and we're going to see how we first retrieve time series. So I'll look, I'll click on that first, on that first item, and I'm going to I want to create time series. What you need to do to create time series is select an area, and I will select it from an asset, an Earth Engine table. This is a tiling system of the project area. I could be using plenty of things like country boundaries or different features. Let me just try to see. Okay, let me just, I've been on Sepal for a bit now, and I probably need to refresh my page. So let me just do that quickly, if you don't mind. All right. Those are the moments that we always love, right? Okay, I'll log out and I'll log in again. Right, so I should have started with that anyway. We want to log into the platform. and you need a password, and you need a login password. The first thing we're going to do is create a recipe to get the time series data to download. To do that, we will select either country boundaries or a Earth Engine asset. And I really hope that that this goes through as I'm speaking. And if it doesn't, maybe I can try to see what it would look like with a country boundaries. Okay, let's just so we have prepared that demo like a cooking recipe. We have those steps produced and they're already there, but it looks like this is not working right now, and I don't know why. Maybe I'll just kill this. Try it. All right. So the idea is that
Remy, would it help if I throw to a couple of questions that maybe Eric can answer in the meantime?
Yeah, there have been some questions in the chat, and
excellent.
It would be awesome if Eric could have a look at them.
No problems. So Eric, I'm not sure if you've seen the first one in the Q&A, but what is the policy in the long run of FAO for SEPL from use by private institutions? You want to answer that one first, Eric?
Yeah, sure. So at the moment, we don't have any limitation on who can use and access the platform. I mean, we have to correspond to the open source, the open source licenses of the software we use and all the packages we use to make SEPL go. I mean, there are some limitations based on those restrictions, but those aren't ours. So, for instance, like Google Earth Engine, which we rely on, is not a commercial. You can't be a commercial entity used to make a profit and access Earth Engine without speaking to Earth Engine, let's say. So we support public, private, intergovernmental, anybody who wants to use it that isn't, as far as we know anyway, using it to as a profit type thing. So does that answer the question? I mean, there are no limitations.
It does. It certainly does. And then there was I guess a related question in the chat, which I'm not sure all of the participants can see, but what is the business model for SEPL? Who pays and how is it sustained? From Adam Lewis.
Yeah, thank you for that question. I know it's of interest to a lot of people. So at the moment, we're completely donor funded. We have some direct donations and some in-kind donations from other people around the world. The business model is to continue to provide utility such that at least a portion of the donor funds, global donor funds, available for climate change, data democratization, innovation, capacity building, those sorts of things are used for continuing to support the project. We are looking to institutionalize the system within a larger FAO or UN based infrastructure, so then it would become supported by the larger UN support structure, financial support structure as well. So those are the things that, I don't know if that answers the question of what our business model is, but I think it's similar to how other UN projects and programs are being done.
Excellent.
I guess.
Lovely, thanks, Eric. I think that answers it beautifully. How are we going, Remy? Do you need a little bit more time, or are we ready to go?
What I suggest, maybe so this part of SEPL is connected to Earth Engine. it really usually works really well. It seems like there might be a connection issue with Earth Engine right now. So what I suggest to do is we move to the second part of the process. So we'll just skip how you download the time series, and maybe as I go with the demo, it functions again. And we can go back to it. And I suggest we go on the how you run BFAST itself. Is that all right?
Yes, for sure. Live demonstrations can be tricky.
We love
like working with kids and animals, right? You should never trust them.
Yeah, let's make sure that we finish that demo before the kids come back, because it makes it even stronger. Anyway,
you're doing well.
What I was saying a little bit earlier is we have worked with the University of Wageningen to start from the R-based version of BFAST, and they also adapted a Python-based version of BFAST, and we have created modules for both implementations. And what I would like to show you is on a specific area. Using graphical processing units, we can really increase the performance and decrease the processing times. So this is a new feature we have in Cepal. You can select in the instances, you can select, you have all the CPUs there, but you can also select the GPU one, and that's the demo I'm going to be making today, using like a very simple G4 GPU instance. Then, and we start an instance because we're going to be running this on the AWS Cepal instances inside the server. This is not going to be running in Earth Engine. It's going to be running locally on our local instances. The module itself is called BFAST GPU, and you can type it here, or you can like scroll through the different tools, and you select it and click it, and that's what you have. So if I go back to while the module is charging, and that usually goes relatively fast, I'll just show you in your folders. Once you do your downloads, you will get them there. So here is your personal space where you can store your data. And if you go under your downloads, you will find a couple of series. In that case, that's the one I wanted to use today, that I thankfully downloaded ahead, where you will get all the time series. And I did a time series going from 2013 to 2021 over a 1 million hectare box. It's like 100 kilometer by 100 kilometer area, and these are the units we're using in this project in CAFI, where the data is being processed by the different countries in parallel. Right. So right, my module is started, and I'm going to be using this that time series that downloaded from Earth Engine to use the GPU version. So I'll select that folder, and it will go directly. So you have like a really simple interface. You have just basically like one simple tab where you load your series, you load your parameters, and you make it run. So that's what I'm doing. I'm loading my folder. I have the different parameters that are associated with BFAST. I can change the frequencies. I can change the models. I can have some advanced parameters that are in the implementation. I will leave those by default. And the only thing I'm going to do is change the dates, because I'm going to align with what we're doing in that project from January 2016 actually to now, to May 2021. And that's it. That's the amount of things that you need to do. And then you just click on the launch BFAST. Of course, I'm saying this and I never know what's going to happen, but this one has run already. Okay, I've had that before. So I'll just redo it again, just because sometimes it likes being is being sent twice. But I hope that still brings us to the point we want. So I'll just redo that really quickly. I'll just reselect that folder. I'm not going to change anything here. I'm going to change my January 2016 to May 2021, and I'm going to launch. And as you can see here, because I ran it already, it runs directly, and it says it's already done. What I'll do is here I'll just change the name of the output directory, and it's going to have to run again for this. And I would just like you to see again, if that runs, how it's progressing. And so you can see here it's launched and it's working. Again, the area we're talking about is 100 kilometers by 100 kilometers, like 1 million hectares. It's got 2013 to 2021 in terms of data. So yeah, that's 8 years. And it's using all Landsat 8 and 7 acquisitions, and it's taking everything. And you see how quickly it's running here. Basically, it's going to take around 10 minutes to run completely, and the similar implementation of the same algorithm inside R using parallelization, using like 16, 32 CPUs would take around 14 hours. So the ratio of the implementation in the GPU compared to the one with the CPUs in R is minutes to hour ratio, so like 60-fold. And thanks to that, we have made like a really good progress. So I'm going to let it run in the back. Again, I'm going to use the cooking show approach, and you will find your results inside a module results. And inside module results, you have a couple of all the different modules get the results stored there. And as you can see, this one is running now, and this one is the one I ran ahead to make sure it's there. So you can find your results there, and you can select and you can see your results. So I guess that's the one I just launched earlier, and I guess that's the one that's coming out. And yeah, that's typically one output. So this is something I can download. So I'll just do that just to show you that I can download it, and that I can use later on. This contains both the magnitudes and the dates of change. You can do a little bit of post-processing to combine that with forest mask. I actually did that, and inside R, and I combined that with another resource, which is the land cover map that was produced within that project again. So I actually took that one here. It's a classification for 2015 with like many different classes, and I just combined that with a with the results from BFAST to try to separate deforestation degradation, and then combine that with the classes of interest. And they are both classes for sorry, I just need to put my password in. There are both classes for savannas and or forest, for instance, because as you may know, BFAST as it's running is blind to the land cover that's behind itself. It's looking at the changes in the indices, not what types of vegetation. So by combining this with a good land cover map behind, you can get very relevant information. I will spare you this post-processing steps, but what I really wanted to do is just show you the results. So yeah, if I just take that in, these are the direct outputs I get. So that's my area. It's in southeast DRC, and I get both the magnitudes and the dates for change. And by doing some post-processing, I can I can look at different amplitudes, and I can select only the ones that I'm interested in. We have various ways of post-processing the monitored change to detect deforestation degradation. And I combine that with the land cover map that's produced, and we can see very clearly. So this is the town of Lumbashi, the yellow areas, the savanna areas, the clear green is very dry open forest, and in red and or pink you will find the degradation. I don't know if you see the colors properly, but you can probably see those big areas here that correspond to big conversions, or those scattered areas here that are within the forest blocks and that correspond to degradation. I don't know if I still have a couple of minutes, Tom?
Sure, yes, Remy. You can take another couple of minutes, is fine.
All right, I'll just really briefly mention. So yeah, we've seen here that we can use Python, we can use GPUs to really quickly process those data. If you look at the dashboard of the project here, this is in the last couple of weeks, maybe 2-3 weeks, working with 6 countries. Each of those little squares is a 1 million hectare square, and this is being implemented and done by the countries. I just took one of them now, and if I'm not wrong, it is probably almost finished by now. Oh yeah, that will that sometimes freezes too. It will defreeze when it's done. Again, 10 minutes, that was my time. But what I want to say is we have those really massive calculation powers that are available for everybody and that are easily used by users. And that's what's currently happening here. And we will be finishing, actually those times are not up to date, and we will be finishing this by next week. And we will have mapped all deforestation, degradation, including very complex places like Gabon or Equatorial Guinea, where we have issues with cloud cover, for instance. One last thing I wanted to show is that we get the data from Earth Engine, we process that using Python notebooks that are embedded into a nice graphical user interface that has been designed by our colleague Pierrick Rambaud. Oh, by the way, I forgot to mention that the project in Central Africa is led by Aurélie Shapiro, who's doing a really amazing job at putting those resources together. Just wanted to give her credit. So yeah, that module designed by one of our developers, Pierrick. I'd just like to show you one really kind of old heritage module that's written in R that time in Shiny, and that is meant for stratified area estimation, and that we can use to sample the results that we just got from the BFAST post-processing. So I will just do that real quick. I will look into that's the combined map that we generate. That's the one I just showed you on screen earlier. I'm going to use that map. It's got plenty of classes. It's got the original classes and the degradation and deforestation classes. Don't worry, take my word. I'll just select some classes that I know are forest and savannas and urban and water, maybe. No, not water, we don't care. And degradation and deforestation, for instance. All good. I can either do a proper sampling or just force one to have an example, and that's what I'll be doing here. And yeah, I just want to show you that we can use those maps immediately to create visualization projects like Collect Earth or Collect Earth Online. And we can immediately, so I can download that as a Collect Earth project, for instance. I can immediately open an interface using Google Earth to check at the points. I can also use the Collect Earth Online project, and that's what I would like to finish on. Just by doing this, it will create a URL that you can directly use to look at data and examine what you've been doing. So these are the points that have been shot, and Yeah, I don't know if I. So I just, these are points that are being just done now. I know that because of these massive areas, that's the example I want to show, that are out there, we are able to map this quickly. This, for instance, I will use the planet data that's behind. So this, for instance, is the second semester of 2016. And if I look at what's happening in 2017, I can see very clearly those changes happening. So these areas here corresponds to this massive place that is being see, those are like massive conversions happening in the southeast of DRC with like medium to large scale agribusiness, very interesting features. But there are also all those dots here in the clear forest that are degradation, that are actually interesting. So I'll finish on this, and maybe I keep my screen on and try to navigate through some degradation points for questions.
Excellent. Thank you, Remy, and thanks for being a true champion in pushing on through the live demonstration issues. Very well done. I just wanted to maybe open up to Jan to see if he wanted to make any comments here from the BFAST side, noting he was in the agenda. Jan, did you want to add anything here, or?
Not immediately. Thanks. That was a nice demo. Well done.
Excellent. Okay, thank you, Jan. So Remy, there's a question for you in the Q&A here from Eric Metzler. Is it possible to run into memory issues with complex models, time series analysis? Is it possible to modify the tile size in order to avoid them?
So again, our Earth Engine connection seems to be just reluctant, just for the sake of demo. So I can't display that. I can't show you that. But that's usually the easy part. That's the one that works, and the rest is more tricky. But okay, that's the way it is. Yes, you can pretty much select any areas you want. The way we have set up a system in this particular project where we have a tiling system with like a 1 million hectare boxes, because they are easy to handle and they are easy to distribute among our users in the country. But you could be doing pretty much the same calculation using any area of interest. The data we are retrieving comes from Earth Engine, and it's being tiled anyway. So there is a tiling system behind, and those tiles are being processed one by one. And the parallelization takes those. You can even modify those tiling parameters if you really want to. That's of course feasible. So yeah. Then that being said, you always run into errors of memory. But the way it's implementing now is fairly robust. What the problems we are encountering at the moment are the moments where we don't have enough data to make the model converge, especially in the places where it's extremely cloudy, or you have data gaps. And there we have to find ways. So either we have to extend our data acquisitions to tier 2 levels, take as much as possible, or in places we have to extend the history period for BFAST in order to set up a model that works.
Great, excellent. Thank you very much, Remy, Jan, and also Eric. We are fast running out of time. Sorry, so we do have to move on. But I suspect there will be a whole series of other questions for you guys as the workshop goes on. So thank you again for the demonstrations, presentations. And now it is my pleasure to pass over to Corinne, who's going to be presenting a demonstration of SITS, the Satellite Image Time Series Analysis. Over to you, Corinne.
Okay. Can you see my screen here?
Yes, we can.
Hi. Hi, everyone. It's a pleasure to be here to present the SITS package. My name is Karine, and we, Rolf, Felipe, Gilberto, and I are from the National Institute for Space Research in Brazil. And before the live demonstration, I will present a brief introduction about SEEDS. So SEEDS is an R package for land classification based on satellite image time series. This package provides a set of functions to deal with and classify the complete time series associated to pixels or spatial locations of a satellite image series or data cube, as you can see here. This package provides a simple API for a complete land classification workflow. So using this API, a user can create and access different Earth observation data cubes from different providers. Users can train different kinds of machine learning deep learning models based on samples, land use and cover samples provided by users in a certain set of categories. Users can evaluate and improve the quality of these samples by using self-organized maps for time series clustering, as you can see here. And so users can classify all time series associated to Earth observation data cubes and perform some post-processing tasks such as smoothing. And so users can produce final maps. So SEEDS is able to access data cubes and image collections from different providers, such as Earth on AWS and Digital Earth Africa, stored in AWS, and data cubes from the Brazil Data Cube project, based on a stack metadata. In this example, we can see the SEEDS function called SEEDS cube, accessing 2 tiles of Sentinel-2 from a bucket, AWS bucket here. So SEEDS provides different kinds of machine learning and deep learning methods, such as random forest and SVM and TempCNN and HasNet, as you can see here. And users can define the type of the method in this SEEDS function called SEEDS train. And users can so provide the specific parameters of these methods using this SEEDS function. The classification in SEEDS is done in parallel. So based in the number of cores and the available memory defined by users, SEEDS divides the Earth observation data cubes and process them in parallel. And after that, SEEDS merges these chunks in the final map to produce the final map, as you can see here. So SEEDS also provides a set of functions for accuracy assessment of the final classified maps. So these functions are based on the good practice proposed by Olofsson and other authors in this paper here. Okay. This is an example of a land use and cover map produced using SEEDS. This is a land use and cover map of Cerrado biome in Brazil that has 200 million hectares here in Brazil. It is a huge biome here in Brazil. This map was produced using around 49,000 samples to train a TempCNN model. And this SEEDS processed the 8 terabytes of Landsat 8 time series in 24 hours to produce this land use and cover map. And this is another example of using seeds. This picture shows a region in the Amazon forest that was deforested in a certain time between 2018 to 2019. So using the complete time series extracted from the Sentinel-2 data cubes, you can detect this deforestation using different kinds of machine learning methods, such as random forest, HasNet, and TempCNN, and with an accuracy around 90%. So this is a brief, just a brief introduction. Now Rolf will show seeds. Let me stop sharing here. Rolf will show the seeds running in an R studio inside CIPO. Please, Rolf.
Okay, are you hearing me?
Yes.
Okay, are you seeing my screen?
Yes.
Okay, thank you, Karini, for presenting the introduction. Good morning, good afternoon, good evening for everybody. My name is Rolf Simões. I work, see here. I'm working in Brazil Data Cube project at INPE. I will present SEEDS, a package to classify satellite image time series. SEEDS is an open source software under development in R language. The idea of SEEDS is to give support to all steps involved in the generation of land use and land cover maps using machine learning algorithms and satellite image time series. We do this by accessing image repository in the cloud, as Karini said. Okay, let's start with the SEEDS demonstration. To run SEEDS in CIPO environment, we need to start an instance in CIPO that we can do in the tab here, terminal. For this demonstration, we choose the instance type M16 that have 16 CPUs and 64 gigabytes of RAM. The amount of computational resources required depends on several parameters. For example, the size of the study area, the spatial resolution of the data, the number of spectral bands of the images to be classified, and the amount of training samples. These are the main factors that influence the demand for computational resources. We choose this instance type to demonstrate classification of Sentinel-2 tile in Amazon biome. Okay, once started the instance, we can open our studio in the apps tab here. Okay, with RStudio application, we have at our disposal a complete R language environment where the packages needed to run SEEDS are installed already. For now, to have the latest version of available SEEDS, you must run the command devtools install GitHub essensing/SEEDS. We are working with the CIPO team to provide the latest version of SEEDS by default in CIPO environment. Here we have the scripts that we will run to demonstrate SEEDS. Okay. SEEDS, this script is compatible with the version 0.12.0 version of SEEDS. We start by running this commands here to avoid warnings. Let's load seeds. Okay. In our example, we will classify a cube corresponding to a MGRS Sentinel tile, 20 LKP. This tile is located in Amazonia, in the border of Brazil and Bolivia. We call this seeds cube function to access the AWS image collection. And these image collections are ARD images that are not prepared to work with satellite image time series. And we need to process these image collections to extract a time series. And seeds do this by default. But for this demonstration, we run this function seeds regularize to make a copy of this process that take several minutes to run the classification more faster. So here we prepared a data cube from 16 days images. Each 16 days images, we prepared a composite image from Sentinel-2 using the package GDAL cubes. And we use the median method to construct this mosaics for each time series dates. So we have here a data cube that starts in 2018 and ends in 2019. 1 year of time series. Okay, so we have this data here. Sentinel-2, T20 LKP. This data was processed here, and we use the same seeds cube function, providing source and the satellite in some parameters to access these files here. Okay, we can see an image of this data cube by calling this function. And we will use we will use a set of samples to extract time series from this data cube to perform training on machine learning model, and then classify a land use map. Okay, this CSV is a set of points with longitude, latitude, start date, end date, and associated label here. After points have been retrieved, we can see an example of the time series retrieved from the data cube. We have this spectral bands from Sentinel, and a summary of the labels. We can see we have 3 classes here in this data set with this amount of samples in each label. Okay, let's go to train the classification model.
Sorry to interrupt, just 1 or 2 more minutes if that's okay. So we've got some time for discussion before we close. Is that going to be okay?
Okay.
Okay, thank you.
Yes, we are almost finished.
Perfect. Thanks
Just
so much.
a couple of seconds and we'll show the results here. We can see the processing. Here we have the logs of each processing workers and the chunks that are then classified. Okay, so we can just plot the results. The output here is the probability of each pixel to be in each of the 3 classes that we train in the model: deforestation, forest, and non-forest. We have the probability in the intensity color. And we can obtain the map by choosing the most probable class. Most probable class here. Okay. Sorry. Just couple of seconds to do this.
I think that it's not necessary to show the SO map because it's
okay.
Just the final map. It's okay because we.
Okay, this is the result of the final map, the thematic map with these 3 classes used to train the model. And I have prepared some examples here, but we don't have enough time to show. I just, to finish, I want to show where users can get detailed information about SIDS in the SIDS GitHub page. And here we have a link to the book of SIDS that where interested users can find a detailed information about SIDS. And that's it. Thank you for your attention, and give the word back to Karin.
Okay, we finished now. Thank you, Rolf.
Excellent, thank you, Rolf and Karin. That was really very interesting. It's lovely to see some of this work in action. We are fast running out of time, so I might just quickly pass over to Gilberto, who I think will be able to facilitate some discussion on this topic much better than I, and to close us out for the day. So over to you, Gilberto. Thanks again, guys.
Right. Thank you so much. So I'm going to really thank both the teams that develop BFAST and the team that develops SITS. And as a preview of what we discussed, what I would like to first reactions to the whole idea. I mean, if you have specific comments on BFAST and SITS, you're fine. If you have more generic comments on this running of applications on CIPO, it's also fine. I particularly would like to hear from our experts, which are, of course, in a position to analyze from the perspective of the users, if they have any reactions on what is the process and what they would expect from the developers and from those who are making an effort to develop tools for CIPO. So would any of our expert group would like to take the floor and make some generic questions? Well, Adam, oh yes. So Adam would like to.
Hi, Gilbert.
And Thomas. So Adam, please, and then Thomas. Yes, please.
Just a simple question, I guess. The capabilities, particularly of CEPL, are just remarkable, and really a testament to a lot of work and intelligent work, as with the Brazilian data cube also. How about the complexity of use? Must be a bit of a, I guess I'd like someone to talk about the complexity of use and the degree of specialization and knowledge that's needed to engage with those tools in practice, and how you get over that hump, particularly in developing countries and places where there may be skills limitations.
Okay, it's a good point. It's a very good point. I would, before Brenny, I will hand it over to Thomas so that he can also make, and Maria Jose. Thank you, Maria Jose. Thomas, please.
Yeah, thank you. Actually, I have the same comment that first of all, this CEPL looks very impressive, a platform, and also the two demonstrations. What I was thinking also was that they are not for, let's say, dilettantes, that it seems to require a significant amount of expertise and training before they can. Okay, the BFAST is probably can be run quite automatically, but what I'm thinking in particular is something that we discussed yesterday extensively, is this uncertainty assessment and how is it incorporated there. We had very nice example of using this collect work directly from CEPL. This was great, but this type of reference data, of course, is not applicable for all the purposes. So yeah, general comment is that it requires some quite an expertise, I think, for the users still, which I don't know, it may be unavoidable. You cannot avoid that requirement.
Okay, Maria Jose.
Yeah, well, I think first of all, I think the philosophy behind CEPL is great, and what is being done is also quite an amazing achievement. And I think if we build on this philosophy, basically what we are building is a collective community of expertise that grows with the use, and therefore we go away from these traditional capacity building approaches. Other thing I really appreciate from CEPL so far is the fact that they are providing a partial service. They're not trying to do the whole thing for the country. And that's also very important, because this also is a potential, very powerful tool to engage countries in improving and in creating their own capacities through collective discussions with other experts from other countries and things like that. So
Someone was asking about the business model. I think that's very important because while moving forward a business model, this needs to be guaranteed. And I think it's already somehow very good that it's based on a UN organization, because that will allow to create a business model which is more independent of particular interest or particular donors, but rather something which grows with the use and grows with sources of resources from many places. No, so having said that, of course, it is technically complex, but is less technically complex or more technically complex than other. I think it's more or less the same. Each of the approaches, they have their own problems and their own technicalities and their own pros and cons. But to me, I think what we have to really focus on here is what CEPAL offers in terms of collaborative effort and real collaborative effort. And also, I believe that it will be extremely important that this collaborative effort in terms of collecting activity data, it should serve two countries and not only necessarily for the ESG inventories. It could serve for other international initiatives, like, for example, what is going on now with the natural capital accounts by the UN, for example, because the information that CEPAL provides is a very fundamental information. And if the country owns this information and is well grounded in, scientifically technical knowledge, that will consolidate also the initiatives. And it will also alleviate the burden that you are thinking that you're doing this great effort just for ESG inventories, right? Which is one of the things that we've been always saying, no? You do monitoring because, not only because you want to report, but this has to be also useful for other purposes, including better management and so on and so on. So I will say, thank you, Eric, and your team for this effort, but let's put the thing in the context. Let's say, I think we should not be lost in the technical details. We should be looking at the overall philosophy on which CEPAL is being built and continue with this philosophy.
Okay, thank you, Maria José. I'm going to briefly address, on the general grounds, a question that were raised by Adam and Thomas. It is the question of complexity. As you see, for example, SITS, which I was involved, but also BFAST, at the outset, they are scripts that you write. And I have 2 points. One is reproducibility. You cannot reproduce a point-and-click interface. You can train people to reproduce what you did in point-and-click interface, but you cannot send a point-and-click interface to someone and say, do it. So when you have a script in R or Python, the great advantage is it can be reproducible. The second point, and I'm speaking of obviously as the main representative of developing countries. From a developing country perspective, I've never believed in dumbing down. And I always believed that you have to earn it. So I think that underestimating, and I've stated from the deep of my heart, underestimating the skills of people in developing countries is something that does not put us forward. So I would prefer to teach the differences between temp CNN and random forest than to have a click-in that does everything for you. I think it's better in the long run, although it's more challenging. But I don't believe there's a certain level of knowledge that we need the countries to be able to have. But this is a very conceptual point of view. It's not meant to be a consensus, but it's obvious based on the own experience of a developing country like Brazil. We always go to the depth of things. But this is something that will be further discussed tomorrow. This is the taste of what you have. And then, of course, I would hope that our experts, if you have more points and more questions, of course, tomorrow we're going to have a very general discussion. I don't know if there are any other questions for the two packages that were developed here, SITS and BFAST. Any open questions? If not, I think we had a very interesting point on the discussion today. Anyone wants to add anything from the panelists' point of view? Tom, Sarah?
No, just to thank everyone. And tomorrow, really, we have a very long slot for the discussion. So I would encourage everyone to join back. And thanks for today. We'll have more demonstrations tomorrow, and looking forward to those.
Very good. Thank you so much. And it was a pleasure having you all. And please have a good evening or good day, good morning. Well, that's whatever is the case. And see you all tomorrow. Many thanks to all of you.